So in these set of notes, I want to teach you how to make a stem and leaf plot. And the stem and leaf plot is a great visual display of numeric data. And generally the data is discrete, but you can also deal with some continuous data as well, such as things that are in the decimals. For a stem and leaf plot, we have these things that are called stems, and the other part that are called leaves. So in a stem and leaf plot, the stem acts as an interval for the data. So your stem is an interval for the data, while your leaf is going to represent the frequency occurring within each interval. And in order to determine stem and leaves, the first step of any kind of stem and leaf plot is to order your data. And if you notice here in our data, it is already ordered in this, if you go down your columns. So we're already ordered. And by ordered, I mean it needs to go from smallest to greatest. So once we have it ordered, we need to determine our stem and our leaves. The easiest thing to do is to find out what your leaf is. Your leaf is generally going to be a single digit. We call it the last or the trail digit of the number. So all I'm going to do is go through my data and circle a single digit for each number, like this. And as you see, I'm circling the last digit in each number. And even in the first set of numbers 1 and 3, there was only one number to circle. So that means we'll understand the number that's left over to be a 0. And so as I go through circling, you can see that what's happening is I'm creating these intervals for each one of these numbers. For instance, if you look at these 12, 17, 18, 18, 19, those fall in the intervals of the tens. 21, 21, 22, 27, 27, 27, 29 fall in the intervals of the 20s. 30, 31 are going to fall in the intervals of the 30s. And you have some 40 intervals too. So our frequency is generally going to be a single digit. And we call it the trail digit or the last digit. The interval is what's left over. So your stem is going to be what's left over. So if you look here, my stem is going to be a 1 for this first set of numbers, a 2 for the next set. So the interval is going to form the range of the data, or it's going to form a place for us to put each leaf into. And so once we know the stem and the leaf, we can actually create the plot. And so to create the plot, here's what we do. On one side is your stem and one side is your leaf. Once you determine stem and leaf, the stems, you're going to write those, not skipping any numbers from smallest to greatest. And our smallest stem here, remember, there's no number in front of the 1, so it's understood to be a 0, just like in front of the 3. So we have 0, we have stems 0, 1, 2, 3, and 4. So we'll write those stems out, and we won't skip any numbers. And what I mean by you don't skip any numbers, sometimes in some data sets, you won't see stems going in order like this. You'll see stems that'll be skipping. So for instance, you'll see stems where you have 0, 1, and it skips 2, and it goes 3 and 4. But you would write all the stems out. Now, once we have all our stems written out, the next thing is to go in the data set, and then we're going to write out our leaves. The leaf is just the actual last digit of each number within the stem. So in this first one, we have 0, 1, so we'll just put a 1 and a 3. And then the next one, we'll put in all the numbers that we have available to us. That's 2, 7, 8, 8, and 9. And what happens is when you start to make this stem and leaf or add these leaves in, you want to separate your leaves or keep them as spread out as evenly as possible, because it's going to show you basically how frequent the values are within each interval. The next one will be 1, 2, 2, 7, 7, 7, 9. Next one, 0, 1, 2, 2, 2, 3, 5, 5, 6, 8, and 8. And the last one, 1, 2, 3, 5, and 7. And so this is the visual display of the data. And your data is organized and it's ordered. And so you can see certain things within this. For instance, we know that the smallest value in this data set is the number 1. And the largest value is the number 47. The other thing we need to always add to a stem and leaf is going to be some kind of key to read the data. And the key is made simply by taking any one of the numbers inside the data and telling me what it stands for. For instance, I can take the first number 0/1 and say that it equals 1. Or I can take 1/2 and tell you that it equals 12. And this allows any reader to read this stem. So now we know that every number, the stems represent 10 digits, the 10th digits, and these inside leaves represent the ones. And again, we're going to use this now to talk about the shape of a distribution. And we'll do that in the next video. But this is how you create a stem and leaf plot.